In this video, we're going to go through section 3.4, which is calculating the least squares regression line. So I was just going to go through one more example of doing this on Desmos and then looking at the output for that regression line. So remember that when I have a data set and I want to add it to Desmos, I'm adding it as a table. So I'm using that plus sign and then the table. And I'm going to type the X and Y values into X1, Y1. So I'm just going to do the X values first. So I've got 2, 3, 5, 7, 9. And then for the Y values, 4, 5, 7, 10, and 15. And so these values are close, so I don't have to adjust the window very much the way that they do in the videos with the larger data sets. Remember that the wrench is where I can adjust the X and the Y axis to mimic my table, right? So if my table had larger numbers, I would change the X axis to start at something a little smaller than the first X and something a little bigger than the last X. Same thing with the Y, something a little bit smaller than the first Y, something a little bit bigger than the last Y, so that I can see all of the data on the graph. Then I want to write the regression line. So remember that for the regression line, we're typing in Y, and then we're going to use the tilde button, which is underneath the alphabet. So Y tilde, and then it's A plus BX to get our linear regression. And so because I have X1 and Y1 in my table, I have to do X1, Y1, sorry. So it's not Y, it's Y1. You don't have to make it a subscript, you just have to type the 1 after it and it'll automatically do that. So Y1 tilde A plus B X1. That will pull the data from the table into there. And so then this output here gives me the information for what my regression line is and for the R and the R squared equation. So if I'm calculating the least squares regression line, that means that I'm going to write the equation. So I had Y1 using my data, so my Y hat is going to be equal to A, which is 0.304878, plus B, which is 1.51829x. So that's my least squared regression line for this data set. Identify the value of R and describe the relationship between the variables. So looking at this, R is equal to 0.9796. So our R value, remember, strength means that it's close to 1. And so what that R value means is that as a value close to 1, this creates a strong linear relationship. Strong positive because it's a positive value. Linear relationship. Okay, so 97%, almost 98%, we would say is a strong value. It's close to 100%. It's a positive number. And then, so as this is always going to be describing a linear relationship. I'm gonna expand this because we don't need Desmos anymore. So remember that the slope and the y-intercept in the context of the problems, my x or my explanatory variable is hours of sunshine, and my y or my response variable is ice cream sold. So we're talking about the relationship between the hours of sunshine and the numbers of ice cream sold. So remember that the slope of a regression line is the amount by which the predicted value, so ice cream sold, changes as the explanatory value, variable hours of sunshine, increases by 1 unit. Okay, so I'm gonna write over here our slope. So our slope means then that for, so 1.51829 ice creams are sold for every 1 hour of sunshine. And then the y-intercept, remember, is telling us how many ice creams are sold if there is 0 hours of sunshine. So 0.304878 ice cream are sold if there are 0 hours of sunshine. And so if we think about that concept, that's not going to make sense in the concept of the problem, right? There's not going to be a portion of an ice cream sold. Okay, the next thing that they talk about is using computer output. And so if I'm looking at computer output, I can write that least squares regression line as well. So this regression analysis goes from volume versus height of some object. So if I look at the output, remember that the constant is the y-intercept. So constant here is the y-intercept when I'm looking at these coefficient values, and that the height is the slope. So that's the slope of this. So if I'm writing a least squares regression line, that means that y hat is equal to my constant, negative 87.12, plus my slope, 1.5433 times x. Okay, so my least squares regression line then is y hat equals negative 87.12 plus 1.5433x. If I'm using the variables that were given, if I'm doing volume versus height, that would mean that I'm doing height. The predicted value of height is equal to negative 87.12 plus 1.5433 times the weight. Okay, so remember that when it's volume versus, oh, sorry, not weight, the volume. They're telling us your x value compared to your y value there. The last thing that they talked about within this was looking at the r value. And so the computer output only gives us r squared. So r squared is 35.8%, which means that r squared is 0.358. Since I want to know r, not r squared, I'm going to take the square root of that number to figure out r. So the square root of 0.358 is approximately 0.598. And so if we think about that, that's kind of in the middle between 0 and 1. right? So that would be a moderate. And then to tell whether this R value should be positive or negative, we're looking at the slope. So since the slope was positive, our R value is also positive. So it's a moderate positive linear relationship. Okay, so that's all that they went through with this section, was going over how to use Desmos to enter your data, get a least squares regression line, use that R value to identify how this linear relationship, whether it's strong, weak, moderate, positive, or negative. They talked about the context of slope, the context of the y-intercept, and then looked at when we have computer output, how we can find that least squares regression line and the R value based on the R squared value. So the key thing was that the R value, because R squared is always going to be a positive value, we can figure out whether R is positive or negative based on the slope of the line.